Hello students, now as we start off with the topic of straight line, let us begin with some of the important terminologies. Now the first one is inclination and slope of a straight line. Right? Let's consider a line as shown here in yellow color, any general line. Now the inclination of the line is defined as the angle which the line makes with positive direction of x-axis and measured in anti-clockwise sense. Right? That angle is called as the inclination. Right? So typically we denote that by either theta or alpha. Now the slope of the straight line, which is denoted usually by the symbol m, is defined as the tan of the inclination of the line. Right? So that's the definition of the slope. So based on the value of the inclination, the slope will be defined. It's clear that if theta is acute, right, if it is less than 90, then clearly the slope will be a positive number. Now if theta is obtuse, that is it's more than 90 but less than 180, then slope will be negative because tan of any obtuse angle is negative. What happens when theta is 90 degree precisely? In this case we know that tan of 90 degrees is not defined, so therefore here the slope is not defined. Right? So that is about the inclination and slope of a line. Now let's move ahead and see some special cases. Suppose we have two parallel lines, right? So what it means is they make the both same inclinations with the x-axis. So if we consider the slopes of two lines to be m1 and m2, then the inclinations being the same, it is obvious that the slopes of the two lines are also equal because the tan of inclinations of both the lines are equal. So the important point to remember is if two lines are parallel, then their slopes are exactly equal. Right? Let's go ahead and see the result for the perpendicular lines now. So let's consider two lines which are perpendicular to each other. Now the first line has the inclination as theta 1. Let's call its slope as m1. And the second line has inclination theta 2, and let's call its slope as m2. Now we want to see if there is any relation between the slopes of the two perpendicular lines. Right. Now as per the definition, we know that m1 is nothing but tan of theta 1 and m2 is equal to tan of theta 2. Now if you look at the triangle, right, so in this triangle we observe that theta 1 is the exterior angle and hence it must be equal to the sum of the remote interior angles, which is 90 degrees and theta 2. So therefore let us write this as theta 1 is equal to theta 2 plus 90 degrees. So now let's take tan of both sides and see what happens. If you take tan of theta 1, that turns out to be equal to tan of theta 2 plus 90 degrees. Now suppose we want to rewrite this as sine of theta 2 plus 90 degrees upon cos of theta 2 plus 90 degrees. Now we know from basic trigonometric identities of allied angles that sine of theta 2 plus 90 degrees is equal to cos of the original angle, so that is cos of theta 2, whereas cos of theta 2 plus 90 degrees is equal to minus sine of the original angle. So that means by taking cos theta 2 to the denominator of denominator, we can write as minus 1 upon tan of theta 2. So what we have got essentially is tan of theta 1 is equal to minus 1 upon tan of theta 2. So now if we replace these tans by nothing but the slopes, we have m1 is equal to minus 1 upon m2. So in other words, what it means is if two lines are perpendicular to each other, slope of one line is negative reciprocal of the slope of the other line. Of course, we can rewrite this fact in other way also, that is simply product of two slopes, that is m1 into m2 has to be equal to -1. So we have to remember this very important fact, that is if two lines are perpendicular, then product of their slopes is always equal to -1.